Okay, this is chapter 7.5, finishing off chapter 7, and now we're going to solve rational equations. So the essential question is, how can you solve a rational equation? And what you will learn in this video is how to solve rational equations by cross multiplying, solve rational equations by using the least common denominator, and use of the inverse function. So let's take a look at all these. Okay, so example 1 is solving a rational equation by cross multiplication. Okay, so what we're going to do here is we are going to multiply x plus 1 times 9 because there's this equal sign here, and 3 times 4x plus 5. And that's what we're going to do. So when I cross multiply, I'm going to get 9 times x plus 1 equals 3 times 4x plus 5. Okay, really simple cross multiplication. And now we're going to distribute. And that will give me 9x plus 9 equals, I'm going to distribute here, and that's going to give me 12x, and 3 times 5 is 15. So I'm going to subtract 9x from both sides so I don't get a negative x. And when those cancel, I get 9 equals 3x plus 15. I subtract 15 from both sides, and 9 minus 15 is negative 6. And then I divide by 3, and x equals negative 2. So I should always check that. 3 over negative 2 plus 1. So now I'm going to check it. 3 over negative 2 plus 1. I'm substituting in x. Okay, that's going to simplify to 3 over negative 1, or simply negative 3. And on the other side, 9 over 4 times my x plus 5 is going to give me 9 over negative 8 plus 5, which is negative 3. And these should be equal. And 9 divided by negative 3 is negative 3, so they check. Okay, so that's how you determine what variable will make this equation true. Okay, example 2 is writing and using rational models. So it says an alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver. Let's get my highlighter out. 92.5% silver and 7.5% copper by weight. You have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver should you mix with the 800 grade silver to make sterling silver? Okay, so 7.5% copper is 7.5, and percent means out of 100. So 7.5% as a fraction is 7.5 over 100. So what you want to do before I go any further, I want to say what we're going to set up. So what we're trying to find is how much pure silver should we mix. So the percent of copper in mixture is going to equal the weight of the copper divided by the total weight of the entire mixture. Okay, so I'm going to take this 7.5, which is the percent of pure copper, or copper mixture, 7.5% copper in sterling silver, and we want to make a mix of 80% silver. So right now we have 92.5% silver. So what the question is asking is, how much pure silver should you mix with the 800 grade silver to make sterling? Okay, so percent of copper in mixture is 7.5, or 7.5 out of 100. The weight in the copper mixture is 20%, which is 0.2. Okay, it's this 20%, and you're going to multiply that by how many ounces you have, which is 15. Okay, 20% times the 15 ounces. And you're going to divide that by the total weight. Well, the total weight is that 15 ounces, and we have to add to it. We don't know how much we have to add, and that's what we're trying to find. Okay, so 20% of the 15 ounces is copper. So the weight of the copper divided by total weight of the mixture, and we want it to come out to be 7.5% copper because the sterling silver is 92.5%. So we know how much copper we have. So we need to know how much silver, and that's why silver is our variable, not the copper. Okay, so now we're just going to simplify this. So 7.5 over 100 equals 15 times 0.2 is 3 over 15 plus x. Cross multiply, I'm going to get 7.5 times 15. So let me just do this over here. 15, 7.5, 5, carry the 2, 7, 0, 7 times 5 is 35, carry the 3, 105, that's 5, that's a 2, carry the 1 decimal place, 112.5. Plus 7.5x equals 300. Okay, so there's our equation. I want to subtract 112.5 from both sides. And that is going to leave me with 7.5x equals, and let's put a 0 here, and that's a 2, and that's a 9, and that's a 9, and this is a 5. And 9 minus 2 is 7, and an 8, and a 1. So we have 187.5. And now I'm going to divide by 7.5, and that'll tell us how much silver we need to add to make sterling. So let me just get my calculator to save time here. And 187.5 divided by 7.5 equals 25. Okay, so we need 25 ounces of silver to make sterling silver. Okay, so that's how you do these types of problems. The toughest part, I guess, would be setting it up. Just keep in mind what you're trying to find. So what you're trying to find is your variable. So you use all the other information known. So you use the copper percentage, not the silver percentage. Okay, so now you should be able to do problem number 13 in your exercise. Okay, so now we're going to solve equations by using the least common denominator. Okay, so in this case, we have two rational expressions being added equal to another rational expression. So let me start by just rewriting it. 5 over x plus 7 divided by 4 equals negative 9 over x. Okay, so as you can see, I have a 4, I have an x, and I have an x. So the least common denominator would be if everybody had a 4 and an x. Agreed? Okay, so I need 4x. So I'm going to multiply by everything by 4x on both sides. So if I multiply this by 4x, the x's cancel, and I get 5 times 4 is 20. Okay? Let me write that so you see what I'm doing first. So it would be 4x times 5 divided by x. And then the x's cancel, and I get 20. Okay? And then in distributing this, I get 4, there's a plus sign here, x times 7 divided by 4. And since it's all multiplication, we can cancel the 4s. And I'm going to get plus 7x equals, and then I'm going to put negative 9. I don't know why there's a 44 here. It's 4x. 4x. So this is going to be negative 9 times 4x, and it's all divided by x, so the x's cancel, and 9 times 4 is negative 36. Okay, so just multiplying by 4x gets rid of the denominators. It's really nice and neat. Now it's just a linear expression or equation, and I'm going to subtract 20 from both sides to solve for my unknown variable x. So I get 7x equals negative 56. Divide by 7, and x equals negative 8. Okay, so there's negative 8 is my x. Let's try that again. 1 minus 8 over x minus 5 equals 3x. Think of this as 1 over 1. 1 over 1. So if I multiply this side, I have a 1. That doesn't matter in our LCD. I have an x minus 5, and I don't know what I'm doing here. That's not 3x, it's 3 divided by x. Okay, so I have an x minus 5, and I have an x. So I need x times x minus 5. So I'm going to multiply everything by my two denominators that I have. X and x minus 5, and x minus 5. So I just list them basically. So when I take x times x minus 5 and multiply it by 1, I get x squared minus 5x. Okay, I'm just distributing here. So x times x minus 5 times 1 is just simply x times x minus 5, and distributing gives me x squared minus 5x. Minus, so that's this minus. Now I'm going to multiply this times this, but the x minus 5s will cancel, so it's just going to be 8 times x, which is 8x, equals, and here the x's cancel, so I'm going to distribute the 3 throughout here and get 3x minus 15. Okay, with a little bit of practice, this gets really easy, and I'm going to simplify by combining like terms first, so it's x squared minus 13x equals 3x minus 5. And since I have a squared here and I don't here, I have a quadratic, I have an, and I want to get it equal to 0. So I'm going to subtract 3x and I'm going to add 5, minus 3x plus 5 to both sides of my equation. And I'm going to get x squared minus 16x plus 5 equals 0. Okay. Is it 5? No, it's 15. I lost a 1. Put a 1 there, put a 1 there, put a 1 there, and put a 1 there. Sorry about that. So now I want factors of 15 that add up to 16, which would be 15 and 1. So it's going to be 15 and 1. The signs are the same, and they're both negative. So my answer is going to be x equals 15 here, or it could be x equals 1. Two possible solutions. So I'm going to put a 1 in here and see if it comes out to be true. And if I put a 1 in, that's 8 over negative 4. So it'd be 1 minus 8 over negative 4. Okay, I'm using the 1 first. 1 minus 5 is negative 4. 8 over negative 4 is negative 2. A minus a negative is plus. So that's going to give me 3. And then if I put it 3 over 1, well, that equals 3. So 1 is the solution. And now I'm going to check 15. 1 minus 8, this one I'll just show. 15 minus 5 is 10, equals 3 over 15. 1 equals, actually, let's just make it easy. 1 is 10 tenths, so I'm going to make this 10 over 10. Minus 8 over 10 is 2 over 10, equals 3 fifteenths. Well, 3 will go into 3 once, 3 will go into 15 5 times, and 2 tenths reduces to 1/5, and that also checks. Okay, so the solutions are x equals 1 or x equals 15. Now you should be able to do problem numbers 19 and 24 in your exercises. Okay, so example 4 is now going to solve an equation with an extraneous solution. So what is an extraneous solution? That's a solution that you get that when you substitute it back into the original function, it doesn't work. You didn't do anything wrong. It's just that the solution doesn't work because of the outcome. So let's take a look at that. So we have this equation, 6 divided by x minus 3 equals 8x squared over x squared minus 9. I just copied it over here so it's front and center. Let me just change something here. For some reason, my pen's not switching. There we go. So first I'm going to do is factor. So I can't factor anything here. So this 6 times 6 divided by x minus 3 is going to stay the same. 8x squared is a monomial, so there's nothing to factor there. But x squared minus 9 is a difference of squares, and that's x plus 3, comma, x minus 3. Okay, and then it's going to be minus 4x over x plus 3. Okay, so now when I look at this, I have an x plus 3, I have an x minus 3, and I have a, oops, I forgot my x here. I have an x minus 3 again here. So I have an x plus 3 and x minus 3, and that's all we have for denominators. So if we have both, we have our common denominator. So what I could do is I can multiply everything by both terms. So let me just put a bracket around here. And I'm going to multiply everything by x plus 3 times x minus 3. Okay, so obviously this will cancel with this, but I don't want to cancel these out because I'm going to distribute. But as you see, this will cancel with that, leaving me with 6 times x plus 3. So that will give me 6 times x plus 3. And I'm not going to distribute yet. I'm just going to leave it like this. And that equals, and this x plus 3, x minus 3, well, the x plus 3 will cancel this x plus 3, and the x minus 3 will cancel this x minus 3, leaving a 1 in the denominator. So 8x squared divided by 1 is just simply 8x squared. And then this x plus 3 will cancel this x plus 3. Okay. Oops. So that's going to be minus, and we're taking x minus 3 times 4x. So it's going to be 4x, x minus 3. Okay, so that's how those all cancel. And so now I want to distribute, and that's going to give me 6x plus 18 right here equals 8x squared. Negative 4x times x is negative 4x squared. Negative times negative is positive. 4x times 3 is 12x. Okay, so since this is a quadratic and there's no x squared on both sides, nothing cancels, I am going to solve this for 0. So I'm going to subtract 6x minus 18 minus, oops, timeout, undo, Control Z, Control Z. Right here, I have like terms. I almost forgot to do that first. So it's going to become 6x plus 18 equals 8x squared minus 4x squared is 4x squared plus 12x. Okay, sorry about that. Now I'm going to subtract 6x and subtract 18. Subtract 6x, subtract 18. Okay, and we get 0 on the left. We get 4x squared plus 6x minus 18 on the right. I can factor out a 2. That would leave me with 2x squared plus 3x minus 9. Okay, so here's how I do factoring of a quadratic where a is not 1. So if I have 2x squared plus 3x minus 9, I take this 2 and I multiply it by the last term. I take a times c. And now a is 1. I have a 3x in the middle. That doesn't change. And now I have a negative 18 as my constant. And then I know that that's going to be x, and factors of 18 that add up to 3 are plus 6 minus 3. But I divided or multiplied by 2, so now I need to divide these by 2. And so this is going to be x plus 3. And this one I can't reduce, so the denominator becomes the coefficient 2x minus 3. And that's how I factor these. If you do it the other way with the x or whatever, that's fine, but this is how I prefer to do it. So now I'm at the point where I have 0 equals 2 times x plus 3 and 2x minus 3. So doing the 0 product property, x plus 3, I said plus, I wrote equals, x plus 3 equals 0, or 2x minus 3 equals 0. So this is going to become x equals negative 3. And this is going to be add 3, divide by 2. So x is going to equal 3 halves. Okay, so great. We got 2 answers. There they are. X equals negative 3 or x equals 3 halves. So now what we need to do, because we're checking for extraneous solutions, we need to check these in our original. So I'll do one in green. So it's going to be 6 divided by, and my x is negative 3, so it's negative 3 right here. Minus 3 is negative 6. That's going to become negative 1. And that has to equal my other side for this to be true. But if I put negative 3 in here, I get 9 minus 9 is 0. So that's not going to work. So that is extraneous. Okay, negative 3 squared is 9. 9 minus 9 is 0. So this is a problem if I plug a negative 3 in, and so is this. Negative 3 plus 3 is also 0. So the negative 3 is not going to work. Okay, so now I'm just going to check my other solution, and I'm going to substitute in 3 halves. So I'm just going to write this whole thing with 3 halves plugged in. 6 over 3 over 2 minus 3 equals 8 times 3 over 2 squared over 3 over 2 squared minus 9 minus 4 times 3 over 2 over 3 over 2 plus 3. So 3 halves is 1.5 minus 3 is negative 3 halves. So that's going to become 6 over a negative 3 halves equals, this is 9 quarters times 8. So I'm just going to do this up here just to save a step. Actually, no, I'm not. Let's just show all my work and then I can simplify. So this is going to be 9 over 4 minus 9. And since the denominators have to be same when you're subtracting, I'm going to put a 4 here, and this is 36. 9 is the same as 36 divided by 4, right? So I have the same denominators. Okay, so that's 9 quarters. That's my denominator, by the way, so I need to move this down a little bit. This is my denominator of my first term on the right. And this is going to be 8 times 9 quarters. And that's going to be minus 4 times 3 over 2. Well, the 2 reduces the 4 to a 2, and 2 times 3 is 6 over 3 halves plus 3. Well, 3 halves, I'm going to just do this step. 3 is 9, or not 9, I'm sorry. 3 is 6 halves. 6 divided by 2 is 3. Okay, so there they are with all these fractions. And then I'm going to simplify again. Negative 3 halves equals, this is going to become 2 times 9, which is 18, over 9 minus 36, which is 27 quarters, minus, and this is going to be 6 over 9 halves. Well, here's a quarter, here's a half, here's a half. So I have to make these all quarters. 6 over negative 6 quarters has to equal 18 over 27 over 4 minus 6 over 18 over 4. Okay. Whew. Okay. So these aren't all the same, so I can't add these. I need to get rid of these. So this is going to become 6 times 4, negative 4 over 6, right? You multiply and by the reciprocal, right? 6 over 1 times 4 over 6, negative. And that has to equal 18 over 1 times 4 over 27 minus 6 over 1 times 4 over 18. This is going to cancel, leaving me with negative 4. Okay. 18, 9 will go in twice. 9 will go into 27 3 times. 4 times 2 is 8 over 3. Minus, and this 6 will make this 18 a 3. And that's 4/3. So 8/3 minus 4/3 is 4/3. So negative 4 equals 4/3 doesn't check. So what did I do? Oh, I'm sorry. Where are we? 8x squared minus 9. I'm just checking my work here. 6 over negative 3 halves, 18 over, why is that negative right there? They're saying this is negative. Oh, it is. Right here. That's where I made my mistake. 9 minus 36 is negative 27 quarters. So that makes this a negative, and that makes this a negative, and that makes that a negative. Woo! Okay, so negative 8/3 minus 4/3 is negative 8 minus 4 is negative 12 over 3. And then that's why we do our check, guys. And so this is going to become negative 4 equals negative 4, and it checks. So my only solution is 3 halves. Okay, so a little bit tedious with all them fractions, but not a big deal. Check your signs. That's why you should check your work when you're done. And now you should be able to do problem numbers 28 and 30 in the exercises. All right, example 5 is finding the inverse of a rational function. So we have this function f of x equals 2 over x plus 3. We want to determine whether the inverse of f is a function and then find its inverse. So in order to do that, we want a graph. I'm going to do it manually just to show you how easy it is to graph manually. And so I want an x-axis and I want a y-axis. There we go. So then I do this, y, x. Okay, then I know where my vertical and horizontal asymptotes are. Let's make that a little thinner and let's make it red. So in order for this to be a vertical asymptote, the denominator has to equal 0. So -3 plus 3 is 0. So if I went over 1 to, let's say -3 was here, and let's make that dashed. Okay, and maybe even thinner. That's better. So there's my line, and I haven't labeled my axis yet. So this would be -1, this would be -2, and this is -3. So this is x equals -3. There's my vertical asymptote. Let me extend it a little bit down like so. Okay, where's my horizontal asymptote? Well, remember it is f of x equals a over x minus k h plus k. So my h is -3, and because minus negatives plus, and my k is nothing, it's 0. So that means that I have a horizontal asymptote. Make it blue. And that is right here. You won't be able to see it unless you go beyond the ends because my axis is thicker. So let's just put that right there. And I'm going to label that x equals 0. So there is my horizontal and my vertical asymptotes. Now I just need to choose a point on either side. So let's pick -2. So f of -2 equals 2 over -2 plus 3, and that's going to equal 2 over -1, which is -2. Is that right? -2 plus 3 is 1, not -1. -2 plus 3 is 1. So when I go left 2, I want to go up 2. So my point is here. So now I know this function is coming down from infinity, going through this point, turning like so. So there's one side. Now I just need to see what's going on over on the other side. So let's do f of -4. And that's going to equal 2 over -4 plus 3, which equals 2 over -1, which is -2. So here I'm going to go left 4 down 2, and that's right here. And I can't cross asymptote, so it's going to do this. Okay, so as you can see, this is a rational function graph. And if the inverse is a function, then the horizontal line test passes. So what I'm going to do now is I'm going to draw a green line dashed, and I'm going to move it around. So here's a horizontal line. And as you can see, I'm only hitting the graph right here. And I'll grab the green line right here. And as it moves up and down, it's only crossing that blue arc once, the hyperbola. It's only crossing it once. Then it jumps over the horizontal asymptote. And now I'm only touching at one location down below here. It never crosses the function in two places horizontally. So therefore, this is a function. So yes, the inverse, f inverse, which is f prime of x, or f to the -1, I mean, f to the -1 of x is, not equals, is a function. And you'd say because it passes the horizontal line test. Okay, so if I do this in Desmos now, 2 over x plus 3, so let me go to Desmos, and I type in f of x equals 2 divide x plus 3, that's what I just graphed without the asymptote showing. And now I'm going to graph y equals x. because if I take the inverse of this now, it's going to be a reflection across this blue line. So I'm going to leave that there for now. Go back here. It says, then find the inverse. Okay, right here. Then find the inverse. So I'm going to write f of x equals 2 over x plus 3. Step 1, to find the inverse, make your function notation y equals 2 over x plus 3. Next step, switch your x and your y. Okay, now that's y plus 3. And then I multiply both sides by y plus 3 to get rid of my denominator. Like so. These cancel. So I have x times y plus 3 equals 2. Okay, so I'm trying to solve for y. So I'm going to divide by x, both sides. These cancel. I get y plus 3 equals 2 divided by x. I need to subtract 3 from both sides, and that will give me y equals 2 over x minus 3. So this should be my inverse function. Let's check it in the graph. 2 divided by x, and then minus 3 for my k. So this is going to be a new function, and I'm going to call it g of x. And it's 2 divided by x. And then I arrow out of that. And was it plus 3? Or minus 3? Minus 3. Okay, so I got to shift that down 6, minus 3. There it is. Okay, so that red function, as you can see, if you reflect it across the blue line here, y equals x, the red is a reflection of the blue. Same with down here. Okay, so there is the function verified by graphing. Y equals 2 over x minus 3. Now you should be able to do problem numbers 38 and 43 in your exercises. All right, example 6, solving a real life problem. And they're taking a problem from 3 sections ago, 7.2. Example 5, where it says you wrote the function c equals 50m plus 1,000 divided by m, which represents the average cost c in dollars of making m models using a 3D printer. Hopefully you remember that because I assigned a problem on that. Find how many models must be printed for the average cost per model to fall to $90. So there's the first thing. We have to find the average cost per model to fall by $90. And then step 2, and then by solving an equation, and B says use the inverse of the function. Okay, so here's what we're going to do. Step 1, write C equals 50m plus 1,000 divided by m, where C is the average cost C in dollars right there. Okay, average cost C. And so we were told the average cost is 90, so that is our C. So we're just going to solve for m by plugging in 90. So 50m plus 1,000 divided by m. Okay. So the first thing I'm going to do is multiply both sides by m, like so, to get rid of this. And I'm going to end up with 90m equals 50m plus 1,000. Subtract 50m from both sides. And that's going to leave me with 40m equals 1,000. And I divide by 40 and I find my m. Okay, cancels. And these cancel. And 100 divided by 4 is 25. Okay, how many models must be printed? M equals 25 models. 25 models must be printed to bring the average price down of a 3D print to be $90. Okay, the other way we have to do it is B using the inverse function. So C equals 50m plus 1,000 divided by m. So what we're going to do here now is we're going to do the inverse. In other words, we're going to solve the equation for m. So it's basically the same thing. So there's a couple ways we can do it. Over here, I multiplied both sides by m to get rid of it, but here I'm going to do something differently. This is going to be 50m over m plus 1,000 over m. When you have a binomial over a denominator, you can split that up into two fractions with one monomial being the numerator of one fraction with the same denominator and the other one being the other, and the sign just goes in between. So m divided by m now cancels, and I get c equals 50 plus 1,000 divided by m. Okay, I want to get m by itself, so I'm going to subtract 50 from both sides. And that's going to give me c minus 50 equals 1,000 divided by m. Okay. So there's a shortcut if this is over 1. So if I multiply both sides by m and then divide each side by c minus 50, well, this c minus the 1,000 is just going to become the numerator of this side. So I'm not even going to put that divided by 1 here. This just moves over here, and that's 1,000 over c minus 50 equals m. Okay, that's a little shortcut trick you might have learned in geometry, but if you don't, here's what I'm doing. C minus 50 equals 1,000 divided by m. Okay, I'm just doing it in one step instead of two, but I guess I should explain it in case you have never seen this. Multiply both sides by m. So it would look like this, and this is gone. And you're trying to get m by itself. So now you're going to divide by c minus 50 on both sides. So I'm going to end up with m, because these cancel, equals 1,000 over c minus 50. Sorry for the sloppy writing. It's hard to write over on the right here. So anyway, 1,000 divided by c minus 50 equals m. Now we know that 90 is c, so then we just substitute. So we say 1,000 over 90. Change color so you know that's what I substituted in. Minus 50 equals m. All right, let me extend this a little bit. So that becomes 1,000 divided by 40 equals m. And again, cancel, and 100 divided by 4 is 25. So again, we're going to get m equals 25 in models. Okay, so either way you want to do it, solve for m, or substitute in 90 and solve for m, or you can solve for m first and then substitute in 90. All right, so now you should be able to do problem number 45 in the exercises. Okay, so that brings us to the end of chapter 5, 7.5, and the end of chapter 7 as well. And these are the problems I assigned, so get to it. Thanks for watching and have a great day.